Hi everyone, myself Praveena. I'm the Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Today I want to discuss about the topic on Lagrange's theorem problems. Already we discussed the basic concept of these Lagrange's theorem problems. Now we'll discuss some difficult problems on that. Okay, first question. Okay, before going through the problems, what about the statement of the Lagrange's? Lagrange's means if let f of x be any function, it is continuous in closed interval a comma b, and it is differentiable in open interval a comma b if there exists c belongs to ab such that what about the statement of that? F of b, f dash of c is equal to f of b minus f of a by b minus a. Okay, this is the theorem statement. Okay, through the statement I have to prove some questions from the Lagrange's. Okay, then the first question now. If already we discussed the 3 questions in the previous PPT, now I discussed with the 4th question. If a less than b, prove that b minus a by 1 plus b square less than tan inverse b minus tan inverse a less than b minus a by 1 plus a square using Lagrange's mean value theorem. Okay, here what we have to prove? Here they are given one condition. We have to prove that by using Lagrange's mean value theorem. Okay, from that deduce the following. What about the first deduction part? Pi by 4 plus 3 by 25 less than tan inverse 4 by 3 less than pi by 4 plus 1 by 6. Second one, 5 pi plus 4 by 20 less than tan inverse 2 less than pi plus 2 by 4. Okay, we have to deduce the following from the above condition. After proving the condition by using Lagrange's, we have to deduce the following. For that, okay, what about the solution for that? Okay, consider first we have to let us assume the function from the given question. How we are assuming that question here? What we have to prove here, that is b minus a by 1 plus b square less than tan inverse b minus tan inverse a less than b minus 1 plus a square. From that, I'm assuming from tan inverse as a function of f of x. That means I'm assuming f of x is equal to tan inverse x in closed interval a comma b for, okay, what about the condition there? 0 less than, a less than, b less than 1. Okay, here we have to prove first f of x is continuous in closed interval and derivable in open interval a comma b. Okay, for that, okay, here tan inverse x. Okay, by using Lagrange's, okay, already we discussed in the previous one, if it is the function from one of the property, if the function is differentiable, then definitely it is continuous. Okay, once observe here, whatever the tan inverse x differentiation, tan inverse x differentiation is 1 by 1 plus x square. If it is differentiable, then definitely it is continuous. Okay, therefore here, if it is differentiable, then that is continuous. Therefore, the 2 conditions satisfied. One is differentiable satisfied. From that, it is continuous. If the 2 conditions satisfied from the Lagrange's mean value theorem, what about f dash of x, f dash of c? F dash of c is equal to f of b minus f of a by b minus a. Here, what about f of x given function? What we are assuming? Tan inverse x. And what about the differentiation? That is 1 by 1 plus c square. 1 by 1 plus x square. Here I am substituting in the formula. Then f dash of c is, okay, this is f dash of x is equal to 1 by 1 plus x square. From that, in place of x I am substituting c. F dash of c is equal to 1 by 1 plus c square. Okay, this is 1 by 1 plus c square. From the above statement, okay, then f dash of c is equal to what? There I'm substituting that function, that is f dash of c. LHS part as 1 by 1 plus c square, and here f of x, what we are assuming? Tan inverse x. From that, What about tan inverse f of b? That is tan inverse b minus f of a as tan inverse a by b minus a. Okay, this is that. Let us assume by using Lagrange's we get 1 by 1 plus c square is equal to tan inverse b minus tan inverse a by b minus a. Okay, from that, okay, if the two, when the conditions are satisfied, if there exist c belongs to ab such that when that condition satisfied this first equation, if there exists c belongs to ab. Okay, from that, that means what? Here a less than c less than b. A less than c less than b. From that, I am squaring on both sides. That is a square less than c square less than b square. After squaring on both sides, I am adding 1. That is 1 plus a square less than 1 plus c square less than 1 plus b square. Okay, then this is that. Okay, from that condition we get directly 1 plus a square less than 1 plus c square less than 1 plus b square. But I am taking the reciprocal. Why I am taking the reciprocal here? Once observe the condition, there 1 by 1 plus c square form. From that I am taking the reciprocal on that. That is 1 by 1 plus a square and 1 by 1 plus c square and 1 by 1 plus b square. If you are taking the reciprocal, then less than will be here greater than. Okay, therefore 1 by 1 plus a square greater than 1 by 1 plus c square greater than 1 by 1 plus b square. Okay, from that 1 and 2 conditions, once observe, there I am substituting that from the first equation here. What about the 1 by 1 plus c square? That is tan inverse b minus tan inverse a by b minus a. I am substituting there. That is 1 by 1 plus a square greater than tan inverse b minus tan inverse a by b minus a greater than 1 by 1 plus b square. Okay, I'll write it as this is in the less than form, that is or from that I'll write it as in the less than form, that is b minus a by 1 plus a square less than tan inverse b minus tan inverse a less than b minus a by 1 plus b square. Okay, this is we have to be proved from the Lagrange's mean value theorem. Once observe once again here, f of x is equal to tan inverse x in the interval a less than a to b. From that we get directly by using Lagrange's we get b minus a by 1 plus a square less than tan inverse b minus tan inverse a less than b minus a by 1 plus b square. This is the result. Okay, from that now let us take that as the third equation. From that now we have to prove that deduction parts. Okay, from the third equation, this is the third equation. Here we have to assume a and b values for the first deduction part. How we are assuming? Once observe the deduction there here once observe the first question from the deduction, that is pi by 4 plus 3 by 25 less than tan inverse 4 by 3 less than pi by 4 plus 1 by 6. From that, first we have to observe this here. From this, we have to assume a and b values here. From that, I am assuming there in place of b as 4 by 3. Okay, b is equal to 4 by 3 and a is equal to 1. There only we get the deduction part. Once observe and substitute. Then here in place of b, I am substituting 4 by 3 minus 1 by 1 plus b square means 4 by 3 square, that is 16 by, that means 4 by 3 square means 16 by 9. Okay, I am substituting there here. That is 4 by 3 minus 1 by 1 plus 4 by 3 whole square less than tan inverse 4 by 3 minus tan inverse 1 less than 4 by 3 minus 1 by 1 plus 1 square. Okay, from that here 4 by 3 minus 1 means that is 4 minus 3, that is 1 by 3 by 1 plus 16 by 9 less than tan inverse 4 by 3 minus tan inverse 1 means that is pi by 4 less than there 1 by 3 by 2. Okay, there we get 2 by 1 by 6. Okay, from that after taking this, after the simplification there, it will get 3 by 25 and minus pi by 4. I'll take it on both sides. Then minus pi by 4, if you are taking on the both sides of that, it will be plus. That means 3 by 25 plus pi by 4 less than tan inverse. Okay, 4 by 3 less than pi by 4 plus 1 by 6. Pi by 4 plus 1 by 6. This is the first deduction part after assuming B as, once observe what we are assuming, B is equal to 4 by 3 and A is equal to 1. For that case only we get the first deduction part. Okay, therefore that is 3 by 25 plus pi by 4 less than tan inverse 4 by 3 less than pi by 4 plus 1 by 6. Similarly, for the second deduction part, again we have to assume some another values of A and B. For that case, I am assuming B is equal to 2 and A is equal to 1. Again, we have to substitute that A and B values in the third equation. What about the third equation? B minus A by 1 plus B square less than tan inverse B minus tan inverse A less than B minus A by 1 plus A square. B minus A by 1 plus B square. There 1 plus, okay, this is the proof. That is the third equation. There I am substituting 2 and 1. Substitute there, that is 2 minus 1 by 1 plus 2 square less than B, what we are assuming 2 and A is 1. That is tan inverse 2 minus tan inverse 1 less than 2 minus 1 by 1 plus 1 square. Here after the simplifying, this is 1 by 5 less than tan inverse 2 minus tan inverse 1 value pi by 4 less than 1 by 2. Okay, that is 1 by 5 plus, I am taking that minus pi by 4 on both sides of the equation, that is plus pi by 4 less than tan inverse 2 less than 2 plus pi by 4. That is, okay, after the simplifying this is 4 plus 5 pi by 20 less than tan inverse 2 less than 2 plus pi by 4. Okay, this is the second deduction from the equation. Okay, then from that, by using Lagrange's theorem, we proved that the given condition, and from that condition we deduce the following one. Okay, this is the concept of this very important question. Okay, next I'll go through the next question for the same concept. Okay, here second question, that means fifth question there, show that for any x greater than 0, 1 plus x less than e power x less than 1 plus x into e power x. Okay, for that, okay, by using, sometimes they are not given particularly, by using Lagrange's mean value theorem, but here if they are not mentioned also, here from the Lagrange's only we get that proof. Okay, from that here, okay, by using Lagrange's, here first I am assuming the function. What about the function here? From the condition here I am assuming e power x as a function. Okay, that is, once observe the interval there, x greater than 0. For that case I am taking the interval 0 comma x. Okay, if you are assuming the function as e power x, first we have to, by using Lagrange's means, first we have to verify is it continuous and derivable. Okay, e power x is definitely derivable. F of x is equal to e power x means exponential function. That is, what about the f dash of x? That is e power x. It is definitely differentiable in open interval 0 comma x. If it is differentiable, definitely it is continuous in closed interval 0 comma x. Okay, if the two conditions satisfied by using Lagrange's mean value theorem, if there exists a real number c belongs to 0 comma x such that f of x minus f of 0 by x, that means, what about the formula for that? F dash of c is equal to f of b minus f of a by b minus a. F of b minus f of a by b minus a. So that I am substituting there, that is, here the interval I am assuming, I am taking 0 comma x, there I am substituting that f of x minus f of 0 by x minus 0 is equal to f dash of c. What about f dash of c here? Here f dash of x is e power x, there I am substituting in place of x as c. That means e power x minus e power 0 by x minus 0 below is equal to e power c. From that, e power x minus 1 by x is equal to e power c. Okay, let us take that as the first equation. Okay, and from that, here if there exists a real number c belongs to 0 comma x, so that I'm taking 0 c belongs to 0 comma x means 0 less than c less than x. Okay, from that I'm taking exponential, that is e power 0, e power 0 less than e power c less than e power x. Okay, once observe what we are assuming, the first equation e power x minus 1 by x is equal to e power c. That means what, e power c is equal to e power x minus 1 by x, right? Now I'm substituting that in the given condition, that is e power 0 less than e power c less than e power x. From that, that is 1 less than, what about e power c from the first equation, that is e power x minus 1 by x less than e power x. Okay, and from that I'm taking that denominator as on both sides, that is x less than e power x minus 1 less than x e power x. So that here I'll take minus 1 on both sides, that is 1 plus x less than e power x less than 1 plus x into e power x. Okay, what we have to show from the Lagranges, this one only, that is 1 plus x less than e power x less than 1 plus x into e power x. This is another question from that. Here, by using Lagrange's, first we have to prove that fourth one, and that is next one is the fifth question. Okay, now I'll go through the next question, that is calculate approximately fifth root 245 by using Lagrange's mean value theorem. Okay, this is another question. First, we proved that tan inverse x trigonometric function, and after that exponential. Now I'm taking that fifth root of 245. Okay, calculate approximately fifth root 245. Okay, without using Lagrange's mean value theorem also, we know that fifth root 245 value from the scientific calculators, but here what they're asking particularly by using Lagrange's mean value theorem. Okay, through the theorem, first we have to assume the function from the given question. Okay, what about the function here? F of x is equal to f of x is equal to fifth root x. Okay, here what we have to calculate the value, from that I'm assuming the function. Okay, here I'm assuming fifth root x, that means x power 1 by 5. Okay, what we are calculating 245 value within the fifth root. Okay, from that I'm assuming there. Okay, and here I'm taking a value 243 and b value 245. Okay, then after assuming that function f of x, there what about the differentiation of the f dash of x, that is x power 1 by 5. Differentiation is 1 by 5 into x power 1 by 5 minus 1. X power n formula, n into x power n minus 1, that is 1 by 5 into x power minus 4 by 5. Okay, this is f dash of x, or else f dash, and what about this is f dash of x, from that what about f dash of c, 1 by 5 into c power minus 4 by 5. Okay, that is f dash of c. By Lagrange's mean value theorem, there f of b minus f of a by b minus a is equal to f dash of c. Okay, there here if the differentiation exists means that the function is continuous. So that means two conditions satisfied by Lagrange's mean value theorem. If there two conditions satisfied means if there exists c belongs to a b such that f dash of c is equal to what? F of b minus f of a by b minus a. Here for that what we are assuming, the interval limit points a as 243 and b as 245. Okay, there I'm substituting that is f of 245 minus f of 243 by 245 minus 243 is equal to what about f dash of c, that is 1 by 5 into c power minus 4 by 5. So 1 by 5 into c power minus 4 by 5. That means here f of 240 Now, after substituting that, now we have to find f of 245 and f of 243 value. Okay, from that f of 245 means what? That is f of 243 plus 2 by 5 into c power minus 5 by 5. That means here what? How we are assuming that c value? C is in between 243 to 245. Therefore, that means c is equal to 243. Okay, therefore here, okay, from the first equation we have to find f of 245 value and f of 243 value, and after that substitute there, that is fifth root 245. Okay, from that from this we get directly fifth root 245 is equal to 243 whole power 1 by 5 plus 2 by 5 into 243 whole power minus 4 by 5, that is equal to, from that we get, that is 3 by 5 whole power 1 by 5 plus 2 by 5 into 3 by 5 into minus 4 by 5. Okay, here we have to find fifth root 245 value, so that from that simplification directly here, what about at the fifth root 245 value, that is 3.0049. Okay, this is the concept for the fifth root of any value, either cubed root or whatever it is. From that, by using Lagrange's mean value theorem, means from the given question we have to assume f of x, and in between that we have to assume a and b values, and first we have to verify is it continuous and differentiable. If the two conditions satisfied, there we have to take c belongs to ab such that f dash of c is equal to this. From that we have to substitute this, that is 1 by 5 into c power minus 4 by 5, whatever it is, from the according to the question, and after that we have to find f of 243 value and all, and substitute there. From that we get directly, we get 3.0049. From the verification of the answer, okay, by using the scientific calculator, fifth root 245 value also 3.0049. From the Lagrange's mean values theorem also we get that same value, so that is correct answer. Okay, this is the concept by using Lagrange's mean value theorem from the given questions. First of all, we are proving that the tan inverse, some condition with respect to tan inverse x, and from the deduction part, and after that exponential form, and after that fifth root of x value. Okay, this is the concept of the Lagrange's mean value theorem. Already we discussed in the previous PPT with the basic questions with the Lagrange's, and some typical questions we discussed now. Okay, next class we will discuss with that other topic, that is Cauchy's mean value theorem. Thank you. Thank you for all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.